A massive ship weighs thousands of tons, still it floats on water. But a small stone sinks immediately. Why? And one more interesting question. Even if a ship floats, why doesn't it topple easily? To understand this, we need two ideas: law of flotation and stability of floating bodies. First, let's recall Archimedes Principle. Whenever a body places in water, water pushes it upward. This upward force is called buoyant force, and the buoyant force is equal to the weight of liquid displaced by the body. Now imagine placing a wooden block on a water. At first, the block moves slightly downward. As it goes down, it displaces more and more water. More displaced water means more buoyant force. Finally, a point comes when upward force becomes equals to the weight of the block. At this moment, the net force becomes zero. The block stops sinking and starts floating. This is called law of flotation. A floating body displaces liquid whose weight equal to the weight of the body. In simple words, for a floating body, weight of body equal to the buoyant force, or weight of body equal to the weight of displaced liquid. This is why ship floats. A ship is very heavy, but its shape is large and hollow, so it displaces large amount of water. And when the weight of displaced water becomes equals to the weight of ship, the ship floats. So floating is not about being light. Floating is about being displaced enough water. Now let's move to second question. If body is floating, will it always remain balanced? No. Floating and stability are two different things. A body may float but still topple easily. To understand the stability, we need two important points. First, center of gravity G. This is the point through which the weight of body acts downward. Second, center of buoyancy B. This is the point through which buoyant force acts upward. When a floating body is perfectly upright, weight acts downward through G and the buoyant force acts upward through B. Now imagine body is slightly tilted. When it tilted, the shape of displaced liquid changes. Because of this, the center of buoyancy shifts to a new position. Now upward buoyant force acts from this shifted position. This shift decides whenever body will back or topple. Case 1. Stable equilibrium. Suppose a ship is slightly tilted. When it tilted, the center of buoyancy shifts toward the dipped side. Now the upward buoyant force and downward weight create a restoring effect. This turning effect brings the ship back to its original position. So ship is stable. This is why ship have a broad base. A broad base helps the center of buoyancy shift properly and create a restoring effect. Now case 2. Unstable equilibrium. Imagine a tall narrow bottle floating vertically in water. If it is slightly tilted, the buoyant force may create a turning effect that tilts it even more. So instead of coming back, it topples. This is the unstable equilibrium. Now there is one more useful point called Metacentre. When a floating body is tilted slightly, the new line of buoyant force meets the original vertical line at a point. This point is called Metacentre. If Metacentre is above center of gravity, the body is stable. If Metacentre is below the center of gravity, the body is unstable. So for a stable body, Metacentre should be above the center of gravity. This is the reason ships are designed with the low center of gravity and broad base. If too much load is placed high above the ship, the center of gravity rises, and then ship become less stable and may even capsize. So remember, law of flotation tells us why body floats. A floating body displaces liquid equal to its own weight, but stability tells us whether a floating body will return after tilting or topple. Floating depends on balance of forces. Stability depends on balance of turning effects. A ship floats because buoyant force balance its weights, and it remains stable because after tilting, buoyancy creates a restoring effect. So don't memorize it, visualize it.